you please share some of your engineering contributions to the industry?
Well, back to physical modeling lab. So Bruce Bramfett and I founded that laboratory, and a lot of good work came out of that. Some of the EPRI work that I did, this high purity steels for utility components, involved 3.5 nickel chrome V low pressure turbine rotor forging. And one of the embrittling elements, in addition to phosphorus, antimony, arsenic, and tin, was manganese. And so I showed in the laboratory that if you take manganese out of that steel, you can reduce the embrittlement potential for the steel, but also maintain adequate hardenability. And based on that work, a prototype forging was made in Austria, Kaffenberg, Austria, at a company known as VEW. Then I got to evaluate some of that, and then several other rotors were made in Japan. So that was a big impact, I think, on the industry. Also improved the toughness of the chromoly V turbine rotor by adding a substantial amount of nickel and some niobium for grain refinement. So we had a finer grain size, and we improved toughness very much. It had pretty good embrittlement resistance. Keith Taylor and I prepared a paper on medium carbon bainitic steels, and it was published in Iron and Steelmaker. I think probably one of the best papers on bainitic steels, and I don't know that a lot of people know about it, but one of the works I'm most proud of. I worked on a number of things where I improved the understanding, such as overheating and burning of steels, and overheating, particularly in roll steels with the high chromium content, we're more prone to overheating. And we wrote a paper on that gets referenced quite extensively. Widmanstadt and ferrite, wrote a couple papers in Met-Trans on that to improve the understanding. Laser cutting of steel, I've written a couple papers on that, and we're still learning. That's an interesting area, what the effect of different steel and elements are in steel on cutting. I wrote a paper on the physical metallurgy of normalized steels. So a paper that gets referenced, and I did a lot of work on accelerated cooling, and you got to see some of my seminar at SSAB. Another interesting area where we have a patent on, Steve Hansen and I, is an as-rolled truck frame rail. So for the Class 8 heavy-duty trucks like the Mack trucks, the frame rails today are or were made from say 1027 steel with or without boron. So you would take a hot band, cold form it, punch holes in it, heat treat it, and then that would become the truck frame. What we did was we rolled an as-rolled shape, which had a thicker flange than web. So there was an elastic, there was a modulus advantage, so you could save weight in the truck. You didn't have to heat treat it. And the microalloyed steel that we used actually work hardened in service, and so the actually fatigue resistance went up. Did a lot of work on titanium nitride technology and adding small amounts of titanium in the steel. I think I converted much of Bethlehem Steel's plate products to titanium bearing, and of course at IPSCO and SSAB we did the same. I worked on the high temperature processing X70 sour service, where we received plates from IMEXA in Mexico, because Burns Harbor could not make the low sulfur steel at the time. And that was successful. We rolled the thickest 7/8 inch thick X70 sour service pipe for the Cantarell pipe project. And then X80, I was involved with X80. Interesting, when I was director of application engineering and new product development. So I was involved with developing X80 in the mill at discrete plate, going to Berg, watching pipe formed and made, evaluating, and then we eventually wrote a paper. That was in the Winter Park Plate Conference in 2011.
Can you provide some examples of your involvement in failure analysis and litigation?
Yeah, one of my first assignments at Homer Labs as an investigator was a gantry crane boom failure. The crane boom came down on top of a ship. It did damage, and I remember it was January 1981. I had to fly down to Sprouse Point at the time, climb up this gantry crane, and it was a plate at the top that held things together. It had fatigue cracks, and for taking pictures. It was whatever, 30 degrees out, and took samples back to the lab, and it turned out it was impact loaded. Somehow they dropped whatever they were lifting off their ship got dropped or bounced, impact loaded, and that caused the crane to come down. The interesting thing is, the next day, a plane down in, I think I flew into Washington, D.C., one of the airports. The plane skidded off of the runway because of the ice. We got a lot of snow and ice the next day. So it was great that I got down there right away. It was one of those things, 3 o'clock in the afternoon, you need to be down at Sprouse Point tomorrow morning. And got a plane reservation, went down. Another thing was, worked on ESR, again, Electro-slag refined, annealed 2 1/4 chrome 1 moly. At the Bethlehem plant, had made 20 tube sheet forgings for the Clinch River breeder reactor steam generator. And the tube sheet forgings, actually there's a lot of holes drilled in this disc. You could imagine a disc that's, 20 inches thick or so, got all these holes and all the piping going through these holes. The tube sheet to hold the tubes in place. Well, we could not pass yield strength, and it was a low yield strength requirement. I don't remember exactly what it was, something like 35 KSI yield strength. We could not make strength in the fully annealed condition. And our competitor at the time made vacuum arc remelted steel, and they had about 0.13 copper. And the Bethlehem plant, the product had 0.03 copper, so a magnitude of difference. Small levels of copper for nowadays. But the interesting thing was we found that the 2 1/4 chromium, the high chromium content, reduced the solubility of copper, and actually you got copper precipitation strengthening in the competitor material, and that pushed them over just to get enough yield strength to pass. We could not pass. We just failed by a KSI type of thing. And we went to court. We went to Department of Energy court. I had to testify in the courtroom. And one of the interesting things, I was involved with the discovery process, and we went around and had to discover all the papers, and Westinghouse was involved, Westinghouse Madison facility. I went there, went through their files with the lawyer, the Bethlehem Steel lawyer, collected a lot of information. And we found that, there were 40 or 50 papers or reports, a lot of them done by Oak Ridge National Lab, on 2 1/4 chrome 1 moly, for this breeder reactor, creep fatigue and corrosion fatigue, all kinds of studies that they did. And most of them did not even mention copper. Bottom line is, the judge said, but the spec says 25 max copper, you should have known. And our argument was, hey, all this work has been done and nobody's even mentioned copper. It was a residual. It's not supposed to be in the steel. Anyway, the rebuttal was we wrote a paper on that to try to set the story straight, even though we lost the case. That was expensive. 20 forgings made, scrap could not be used. I got involved with the Northridge earthquake. So out in the Northridge area, Los Angeles, in 1994, the Northridge earthquake occurred. 1998, we learned that some of the structural shapes made in the Bethlehem plant were in buildings. There were 400 buildings. As of 4 years later, no law cases are settled yet. 400 buildings damaged were the column, the structural column that was a rolled shape, and the girder that attached for each floor. At that, where they joined, there was an issue with how the column and the girder joined. But anyway, Bethlehem Steel got sued. We had material there. I went into a number of buildings. On the fifth floor, there's a crack. Go up in the ceiling, take the ceiling panels down, and with the ladder, I'm taking pictures. A lot of cracks. Went to Failure Analysis Associates, who the outside testing lab that tested some of the material showed that Bethlehem Steel met properties per specification. But yeah, 400 buildings with cracks 4 years later, still not repaired. I don't know what happened with that litigation. Bethlehem settled out of court, but we supplied product to spec, but the case would have just kept dragging on. You still kept paying the lawyers. So for some small amount, they settled, and I think that was a wise thing. And then I got involved with the Atlanta Summer Olympics pipe bomb, where an ATF agent, that's alcohol, tobacco, firearms, and explosives, agent came in. He had a piece of the pipe for the bomb. And so what could we determine in a laboratory? And we determined that it was 1022 steel. It was about 1/4 inch thick. I could not find any welds, so it had to be a seamless pipe. It was low copper, so presumably made from an integrated steel company. That's about all we could tell. So I don't know if that was all that helpful to the ATF agent, but I had read later that the nails that they put inside the pipe bomb, they were actually, the nail manufacturer has some marking on the nail head, or right below the head of the nail, that you could tell what plant it was made from.
So through all your work and across the industry, tell me about some of your involvement in various capital projects.
So capital projects, if you ever have an opportunity to get involved with capital projects, they're high visibility, get a lot of attention. It's a lot of work, a lot of pressure, but in the end, the rewards are great. So I highly recommend if you can be part of that, to try to become part of that. I was involved with a 10,000-ton forging press installed at Bethlehem Steel, which is now part of Lehigh Heavy Forging. And we were involved with the modeling lab and doing work. And a kind of interesting story about that was I had to present to the actual people the forging experts, the guys running the press that know much better than me. I'm giving them a seminar. And it worked out okay, but I was pretty nervous for that talk. I was involved with the ADCO unit, the adjustable cooling unit at Burns Harbor, which is long gone, and there's a new unit out there that you well know. Very interesting, developing all the products and starting with the commissioning of that. And some of my seminar came from that experience. Been involved with Molpick. So you know I've written a literature review on that. I had joined IPSCO at the time, right before QL5. They were building QL5 and normalizing furnaces. I started at that point and made input and helped to develop what steels we're going to make, what products we're going to make. So designing the chemistry, the MSPs, and melt shop practices. Normalizing furnace, same thing. The R&D facility, which was a experience of a lifetime, to be asked to design, construct, order all the equipment, hire the staff, write all the job descriptions, and then manage the facility for 10 years. That was, I learned so much. I mean, I even picked out the carpeting, the paint colors. I mean, it was incredible. I just learned so much through that experience. I guess maybe that's enough on that.
When were you the happiest in your career?
Happiest when I'm doing good research, surrounded by good people, writing excellent papers. And I think there's a lot of emphasis on papers. Oh, Bodnar just cares about writing papers. No. I care about doing good work. And if you write a paper, it's kind of win-win for the company and the individual, because the company gets the best work product. It's really polished, it's really well done, it's really researched, has all the references. So I really think that's been good. When I was working the course on the research center, that was like 2 years in the making. From the time they said design the facility to the time we opened, that was almost 2 years. When I've worked, when I've supervised people, I think that have been successful, I get a lot of satisfaction out of that. And when I collaborate with people, I mean, we talked about, of course, niobium particles, and Sunday Abraham, who's taken my job as the director of R&D. I mean, there's many nights where, okay, I'm leaving at 4:30 tonight, and we start talking about coarse particles and mechanisms and research and what's going on, and before we know it, it's 6:30. Oh my God, but yeah, just totally lost in the moment, just so into it. Really, that makes me happy.
Throughout all your work, when did you struggle?
Biggest struggle is when I reported to management that really didn't understand what I was doing, didn't appreciate what I was doing. I'd have meetings and they'll say, tell me again what you did, what you do. Very frustrated. It's hard to get motivated under those circumstances.
Do you recall any significant experiences working with colleagues that you can share?
Yes. When I started at Homer Labs, the director or the vice president of research, Don Blickweed, he was a MIT graduate, PhD, and he was a student of Professor Morris Cohen, very famous professor, probably the professor that's probably done the most work on steel. And interestingly, Charlie McMahon, who was, one of my advisors at Penn, was a student. George Krauss at Colorado School of Mine was a student of Morris Cohen. Well, anyway, Morris Cohen was under contract. He would come to Homer Labs a couple of times a year. And of course, I knew the name. I got to meet this guy. He's a giant in the area of physical metallurgist. So every time he came in, I made sure I would have an appointment with him for a half hour or so. And any engineer could go meet with him, say, I'm working on this, and how would you go about doing this, or what's the best way to solve this problem, or whatever. And Steve Hansen, also as an MIT graduate, studied under Morris Cohen. And Steve was always there. And I didn't know Steve. The first time I was there, I described the problem. So the first 15 minutes, you're describing the problem and how you can help. And then in that last 15 minutes, Professor Cohen would give you advice on what to do. And his prize student, Steve Hansen, was there as well. And I've learned a lot from Steve, his comments in those meetings. And I thought, well, I want to work for this guy. He's really, really, really sharp. So that's really how I got to meet Steve Hansen. And unfortunately, Morris has passed away, but really good guy. Working with Bruce Bramford, I've touched upon this before, is encouragement to get involved with societies, get on committees and share committees. You just learn so much. Write papers, review papers, read papers, go to conferences, start the laboratory. I mean, I would have given up if he, we would turn down management and say, no, you're physical modeler. We're not going to do physical modeling. And we plunged ahead and did it anyway. And I probably wouldn't have had the courage without him. Andy Goodman, he was a project engineer for the R&D facility. I probably talked to him every day for 2 years. I mean, just an excellent project manager for the project. I learned so much from him. He had a temper too. I remember I had made a drawing where all the equipment goes, and we had a geometry equipment, so geometry testing. I moved the equipment to the corner because it's portable. You can move it around the lab. And he put the outlet and all the electrical there. And I said, well, we're going to use this over by this furnace over here. Oh, how could you do that? Because now we don't have electricity over there. So he was really mad at me. But yeah, I can remember when he retired, I spoke at his retirement, gave him a big hug. And then, working with Sunday Abraham, I talked about, discussions, technical discussions with him. We could get lost for literally hours, after work, and we just totally lose track of time.
Did you and your research group receive any honors or awards in your career?
The group has won a lot of awards. I'm very proud that since 2009, and even after I retired now, the group has won at least one award every year. And it's people are doing good work. I'm really proud of what's been done there. I've been very fortunate to win numerous awards over my career, including 24 best papers, which I'm really proud of. And some of the awards, so, the Institute of Metals, we've won a number of times. The Kelly Hunt Award, we've won a number of times. The Gil Spike Award, best paper on the utilization of physical metallurgy, I've won that 4 times. I'm very proud of that. Michael Tannenbaum Award was the best paper given at the Mechanical Working Steel Processing Conference. And then won the Jacques Lucas Award. This is given out by the International Metallographic Society for the best poster paper. And it's a very prestigious award, and there's some money that comes with that too. I'm very proud of that.
Are there any awards that you are particularly proud of?
Yes, particularly the Fellow Awards, becoming a Fellow of ASM International, formerly American Society for Metals, and then AIST, which is part of AIME, of course. I'm a distinguished member and Fellow as of 2018. And to win those kind of awards, they're based on your peers, and it's peer recognition, that when your peers say, hey, you deserve to be at this level. And to join, like John Spear, Bruce Bramford, and George Krause, and other people that Steve Hansen have won these kind of awards, you're part of a peer group now. It really makes you feel good.
Were there any awards that were totally unexpected?
Yes, there were. The Charles Pankow Innovative Applications Award, I had no clue that was coming, and that was given by the Civil Engineering Research Foundation, and that was for working on high-performance steels, including developing of HPS 70W. I'm also a fellow of Alpha Sigma Mu. It's kind of like a engineering honor society I received that in 2012. Had no idea that was coming. We won the Charles Hatchett Award 2012. That's for the best paper on the use of niobium. Had no idea that was coming. And then your own committee, the Rolling Technology Committee of AIST, gave me the Norm Hodgson Award. And I worked with Norm Hodgson. I knew Norm Hodgson at Burns Harbor. He's since passed away. But yeah, that was very, very touching. I still have that in my office.
You have your PE license. Why did you pursue it, and has it helped you out in your career?
Yes. So, I started at research, metallurgical services investigation, and we were involved with litigation. And so if you have your PE license, professional engineering license, the legal system accepts you as having a broad knowledge of engineering. So if you don't have your PE license, but you have a PhD and you're a world expert in some fine area, you start to the questioning starts to deviate from that topic. Then they may say, "Well, you're not an expert in that area. You don't have basic knowledge." So I think if anybody's going to be involved with litigation, and metallurgists can well be involved. I mean, I've been involved during the course of my career several times. You want to have that PE license. So that's really the main reason. And it came in handy when I had to testify in court for the Clinch River breeder reactor tube sheet forging issue.
Rick, switching gears a bit, how long were you a manager?
23 years.
And what kind of groups did you manage?
I spent 9 years as a research supervisor at Homer Labs. I had, I think there were 3 or 4 groups I managed during that time, but in the product development and applications technology areas. I also was director of applications technology and new product development when I first started. At that time, there were 3 plants, so we had Mobile, Montpelier, and Regina plants. Also in that position, I had responsibility, QA responsibility, or quality assurance responsibility for the 5 cut-to-length lines. So that was a very, very busy time. And then the director of research and development for 10.5 years.
You managed a number of labs throughout your career. Can you name them, and how did this experience help your career?
At Homer Labs, switching groups and reorganizations. I ended up managing a whole lot of labs. We had a pilot hot rolling mill and pilot cold mills. So we could actually roll plates, accelerated cool plates in the lab, simulate the hot strip mill product as well. I had the chem lab, the light microscopy lab, electron microscopy lab, heat treat lab. We had a quenching and deformation dilattometer, creep and fatigue and fracture labs. I also had finite element analysis area where we have workstations and engineers doing design, thermal cutting and welding lab, and managing all of these labs put me in an excellent position to design an R&D facility and manage an R&D facility.
In your own opinion, what are some of your major tenets as a manager?
Number one is, and most important, is hiring good people. You got to spend time and make sure you hire the right person, even down at the co-op level. I mean, we would take people out to dinner the night before, kind of break the ice, make them feel comfortable. They interview better the next day, and then spend the time with the person. If you don't hire a good person, it's going to create a lot of problems. So if you hire a good person, that'll alleviate problems and maybe extend your capability if they have the skill set. You have to model the way. If you want people to act a certain way, you have to model the way. You treat others the way you want to be treated. Be honest with people. I'm not sure managers always do that. People would ask me questions, and I would say, I don't know. Try to find out, or I know, but I can't tell you for whatever reason. I never would assign work that I wouldn't do myself. To delegate the stuff you know the best. And most managers don't do that. It's hard to give away when you become a world expert in an area and then you become a supervisor. Of course, you want to continue doing what you know best. That's the stuff you need to delegate and need to focus on things you don't know. And you can see a lot of examples where people don't do that, but that's what I try to do. You always have to have a plan, particularly when there's a meeting. You got 20 people in the room, and if there's no agenda, there's no plan, you're tying up a lot of people. There's a lot of time and money being lost. So there always has to be an agenda or plan. Try to keep people informed. I know as an engineer, I want to know what's going on. Try to inform people as best you can. Try to give big picture on things. If people understand why they're being asked to do something, they maybe can bring new ideas to the table. Although over the years there have been people that work for me, don't tell me why, just tell me what to do and I'll go do that. So you have some employees like that. But I think in general people want to understand why you're doing something, and it allows people to buy into what you're trying to do. Be open to new ideas. I always have a plan. I have an idea. Okay, this is what I'd like to do. And somebody will raise their hand and say, well, I think I got a better idea. I'm quick to switch gears. Okay, your idea's better. I agree. Let's do it. Got to build relationships with people, not just hello in the morning and goodbye at night. Spend some time, try to get to know your employees and build trust. And then to be an advocate for your employees, that people raise issues, you may not know the answers. You have to have the courage to go to management, not with every little thing, but those things that matter, that they're important to your people. You need to stand up for your people and be an advocate. And you don't always see that being done. But those are the things I try to do as a manager. And I can't always learn those from the book either. So you learn from experience.
You talked a bit earlier about hiring interns and co-ops. You've hired 43 interns and co-ops as a manager of SSAB R&D over a 10.5-year period. Why do you think hiring interns and co-ops are important?
For a lot of reasons we've already discussed. Even the co-ops, they contribute in that research. And in most places within SSAB Americas, people have way too much to do. You can't do everything. There's not enough time. So if you have a good co-op, they can help out and do the job. If you hire somebody that's not very good, you have to redo things, and it just takes too much time.
So what has been your experience with diversity?
Diversity. So I guess my big experience with diversity was working at Bethlehem Steel. And at that time, when I started, Bethlehem Steel, particularly in Bethlehem, about 50% of the engineers graduated from Lehigh University. Now, Lehigh University is an excellent school, and I took classes there. So there's no knock against that, but we'd have meetings and brainstorming, and when people come from the same place, you're not getting a wide variety of ideas. They all been trained to think the same way, and so the brainstorming sessions, in retrospect, were not that impressive. And when I came to work for IPSCO, you can imagine we're going to start up a heat treat line. And we had people from Algoma Steel, and we had people from Bethlehem Steel, myself and Steve Hansen, and we had people from U.S. Steel, and people from Oregon Steel Mills, which is now Evraz. And, we sit around, what grades are we going to make, and what products are we going to make, and how are we going to make it? Well, the Oregon Steel, we did it this way. U.S. Steel, we did it this way. Bethlehem, we did it this way. At Algoma, we did it this way. And then we would take the best of the best ideas. And I can remember walking out of some of those meetings, oh my God, just incredible. Just so powerful. And so that's when it really hit me that, no, you don't want all Colorado School of Mines students. John Spear would hit me over the head probably, but, you want a diversity in schools. When I was hiring, I want the best people. I don't care if they're Chinese, Indian, Russian, whatever. I want the best people I possibly can find. And that's just going to add to the diversity. So different nationalities, different countries, different schools. I think it's better for the company.
What are your likes and dislikes as a manager?
I like seeing people be successful. I mean, in sports too. I'll watch. I love watching people be successful. There's a lot of gratification, particularly if I was able to guide or help someone to be successful, win for the company, win for the person, and win for me. What I most disliked was performance appraisals, mid-year reviews, end-of-year reviews. And I used to put a lot of time and effort into it because it's the person's record. This goes on record. And I often would add things that people, if they did their self-appraisal, didn't even write in themselves. It's an important job. It's awfully unappreciated by the company, unappreciated by the person you're reviewing. But I always felt it needed to be done right, and I put a lot of time into it, more so than the average supervisor, I think. Another thing that I dislike is reading something that's poorly written. There's a lot of publications out there that are poorly written, should never have been published. And we all have too much to read, and I'm the person, if I'm targeting a subject and this accelerated cooling, I'm going to read every paper, everything I can possibly find on a subject to become knowledgeable. And there's a lot of junk out there. And one thing a goal that I used to give my people is try to write one paper a year. I say this to you too, in your position. And one good paper. And I remember a lot of young engineers, we want to publish this and that. We want to build a resume. No, we're not going to publish junk or more, very incremental stuff. Good papers that are meaty, that have new things to say, we'll publish that. I try to do one good one a year. So I say that. So in my career, I think I have 112. They add up. But then you got people working for you doing the work. I'm a secondary author, contributor, but secondary author. But I think that's important.
So when did you first learn about AIME?
In graduate school. So remember TMS, the Metallurgical Society, Iron and Steel Society, and Metrez. That was the publication that everyone wants to have their, the most popular, best reviewed journal. That's where you want your stuff published. And fortunately, I've had, several articles or papers published there. And I'm so happy to be part of this thing, and I congratulate AIME for their 150th anniversary, and to do an oral capture during such a time is a big thing.
What technical societies do you belong to, or did you belong to?
Well, I was involved with the Iron and Steel Society, which became AIST, and ASM, for a long time, most of my career, both societies. And then TMS, I've kind of been on and off. I'm a member at the moment, but several times I've lapsed. There's not a lot of ferrous metallurgy in TMS, and they're trying to get strong again, but it's been cyclic over the years. The Heat Treat Society, the International Metallographic Society, the Pennsylvania Society for Professional Engineers, and the Association for Women in the Metals Industry. I thought it was very important to support those women, and particularly those women working for me that are involved with the society. So I was a member for 10 years in that society.
What is or was your involvement in these societies?
Well, ASM Lehigh Valley Chapter, I was chairman of the Young Members Committee. So you have to bring in a speaker and you give out the Young Members Award, Outstanding Young Member. I got involved with the Historic Landmark Committee, also in that chapter, and that was a lot of fun. And then I was involved, ASM also had a ferrous metallurgy committee, and I was involved with that and actually helped organize 4 conferences. ISS and AIST, I was a founder of the heavy forging. I started working on heavy forgings. There's no place to give a paper. So you do good work, where are you going to give a paper? So we actually started the heavy forging committee. That lasted for only 4 years and then died as I moved on to other things. I was the chairman of the Mechanical Working and Steel Processing Division Executive Committee. We had our own logo with a lot of things that we did that I'm proud of that. And then as a board member of the Iron and Steel Society, representing essentially the Mechanical Working and Steel Processing Division. And then I was chairman of the Product Physical Metallurgy Committee, which is now in AIST, it's the Metallurgy Processing Products and Applications Technology Committee. So it's continued on. I am a member of the Plate Rolling Committee, although we have other members at SSAB like yourself. Congratulations on becoming chairman of that committee. And Kent Peasley Junior Faculty Award Committee, I did that for 6 years. That just came to an end. And the last 3 years, I've been on the Kelly Hunt Outstanding Award Committee.
Some of your society work is focused on recognizing history. Tell me about your accomplishments in this area.
Well, Historic Landmark Committee at ASM, I got 2 historic landmarks recognized. One was Beth Forge, not really Beth Forge, but now it was Beth Forge, but in 1898, they took tool steel and really developed the high temperature austenitizing heat treatment that gave great properties. So interestingly, you want to heat treat at a very high temperature for high speed tool steels, and that made high speed tool steels possible. And then the Gray Mill, actually a steam-driven 48-inch mill, rolling mill that made many of the sections that went into large buildings that expanded the skylines of many of the cities in the U.S. Very proud, and that operated from 1908 to 1995. Also wrote the history of the Mechanical Working and Steel Processing Division of ISS. That was back in 1995, so that was not a complete, but it was complete up to that time. I wrote for the preliminary program and final program for one of the Mechanical Working conferences that when it was in St. Louis, Metallurgical Tidbits on St. Louis. And we talked about the Eads Bridge, where the first alloy steel was used in the bridge, for example. And then recently, the history of Bethlehem Steel's research department, I contributed to 2 of the articles. One on essentially summarizing all the work that was done in accelerated cooling and direct quenching at Bethlehem Steel, while Homer Research was still around. And so that Bethlehem became defunct in 2003. And then another paper on vanadium steel custom shapes, such as forklift mast section, truck frame rail section, and Bruce Bramfett was a co-author on a joint bar, so joining railroad sections, rails together with a joint bar. Formerly was heat treated. He developed the vanadium as-rolled product.
You have authored numerous papers and helped to organize 15 conferences. Do you care to comment on some of the lessons learned?
Yeah, I remember Charlie McMahon telling me about publications. And he said you want to publish in the hot areas, the areas that people are interested. If you publish a paper on some secure topic, the paper's not going to get read and it'll be lost. And don't be afraid to put forth controversial ideas. So even if you're proved wrong later, put forth those. Don't be afraid to put forth those ideas, because it'll push the knowledge forward. I mean, it'll people say, wait a second, that's I don't think that's true. I'm going to do this experiment and continue the development. So you kind of spur developments. We had Brian Pickering at the Mechanical Working Conference a couple times. He visited Homer Labs. I was happy to meet him, and he's written another great book. Forget the name, Design of Steels, something like that. Excellent book, textbook. But I asked Brian Pickering, I said, so Brian, what do you think of the Mechanical Working and Steel Processing Conference? And he says, the conference is very good, but people are too nice. And in the old days, people were it was very controversial. People would debate and get up and, argue over, certain metallurgical facts and or data, and present data, in rebuttal, and then this would be captured as part of the discussion in the conference proceedings. It would be really incredible to go back and read some of the conference debates of some of those old papers, which I'm very happy that we at the research facility, SSAB, we acquired George Krause's personal library collection, and Bruce Bramfett, who obtained quite a lot of Homer Research Laboratory library books. We've acquired that at the research facility. So there's a lot of good information, and old information 40, 50 years ago, still germane today. And some of the discussions are very interesting to read. The other thing Brian told me, he says it's very interesting about attending conferences. So when you're a young engineer, perhaps, attending a conference, you don't know very many of the people there. And if you show up, you're sitting in the audience, you're looking around, I hardly know anybody. And then you get in the prime of your career, and you've been active, you've organized conferences, you've chaired numerous sessions, you've been chairman of committees, people know you, you know most of the people there. And people used to say, when I went to the Mechanical Working Conference, and we had attendance of maybe 300 people, I knew most of the people. And then when you get to the end of your career, like I am now, and there's a lot of young engineers that I'm sure are going to be at AIST Tech that I won't know. And then there's a lot of people that I know that are deceased or are retired that are no longer participating. And so you come full circle from, initially not knowing anybody to the end not knowing anybody, or not knowing very many people. So I thought that was kind of interesting in Brian's perspective.
How has societal membership benefited you in your career?
Oh, contacts. So I'm not the smartest person in the world, but I know a lot of people. And people ask me, you know, hey, where can I get information on this? I know who to call. I know who to contact. That's been very successful. And if you're not going to conferences and not meeting people and not meeting the experts in your field, you know, it's a great way. And particularly organizing conferences, like on accelerated cooling. So who are the experts in the world? I'm going to write a letter. I'm going to invite them to present at my conference that I'm organizing. You get to know those people over the years. It's very valuable. Giving papers and particularly giving feedback. And I remember as a young engineer, so many times Professor George Krause in the audience always asked a question. And sometimes I didn't know the answer. Or sometimes I'm like, oh my God, it's a great point. I'm going to go back and read about that. Or I'm going to go do that experiment after leaving. And then you get to the point where you can pretty much figure out what kind of questions people are going to ask, you know. But yeah, George, that was great. I learned so much from his questions. Learning, going to conferences, listening to papers and learning, reading papers and learning, asking questions and learning. Practicing management skills. There's so many management skills. A chairman of a committee, how to run a meeting, how do you keep the meeting going, how do you draw out the people. You see a lot of times where AIST, well, here's the agenda for the meeting. Well, wait a second, we need to also talk about this and this and this. You should be adding to that, enhancing. Don't just rely on AIS Tech. They have their staff is great and all. They have their perspective and maybe what minimum needs to be discussed, but you can do other things beyond what the normal. Visiting competitors, going on tours. So I used to go on tours all the time and see competitive mills. You learn so much. Public speaking, you improve your public speaking. And in my case, Bethlehem Steel, we lost money a lot of years. It's tough to get to conferences. The way I got to conferences is write a paper. So, but I'm the committee chairman. It doesn't matter. So somebody else can step in and do that. Somebody else can't step in and give the paper. So once you get a paper approved, you are going to the conference. And that's what I did. Try to do one paper a year, try to get to the conference. And I got to conferences.
How do you see technical societies benefiting people in the industry today?
Many of the same ways I talked about. I like what AIST is doing now. The visualization, and of course SSAB is a member of Purdue Northwest and their Center for Simulation and Visualization. Digitalization and all the things going on with digitalization now, and I think it's a hot topic. Decarbonization, another hot topic, and SSAB is a leader there. All the training courses, I think, are excellent. The competitive awareness, you got the tech briefs in all the societies, and the technology roundups. You're involved with the plate mill roundups and what our competitors are doing. I think that's all really good information to get, and also safety. Now, there's emphasis to safety within the society, good articles in the magazine every month, talking about Iron and Steel Technology magazine.
If you were to recommend AIST or ASM International to a new graduate, what would you tell him or her about it?
Many of the same things. Opportunity to meet people and contacts is just so key and so important to my success that, like I say, a lot of times I may not know anything on a subject, but I'll know who to call, who to ask, who to get guidance from. Listening to reading papers, you improve your knowledge. Giving papers, getting feedback through Q&A, improve public speaking, learning management skills, learn how to run a meeting, learn how to organize a conference. And, I've been around, you see things not done so well and some things that are done well. And, you learn from that.
In your opinion, what can we do to attract young people to the industry?
I think people need to see steel mill better if it's a clean mill like we have at SSAB. So they have no idea. I think people outside of the industry have no idea what a steel mill has, what it does, what the people do, what kind of jobs are even available. And so I think it's key to go on a mill tour. And I think it's key to have a young person like yourself that's very impressive, and knowledgeable, and a shining star, a rising star, come speak to kids. So that I can speak with students, and I do, but I think they can relate better to a younger person, and and I encourage you to do as much as you can, and will help with the recruiting, I'm sure.
What milestones in the industry do you think had the biggest impact on it?
When I started in the Bethlehem plant, it took 8 hours to make a heat in an electric furnace. Now you have ultra high powered electric furnaces, 40 minutes, you've made a heat of steel. The electric furnace is so flexible, there's an economic down time. You just press the off button, you power off. If you have, blast furnaces and BOF shops, it's hard to shut down that blast furnace. Continuous casting, the quality's got so much better and faster to make than ingot casting. Thin slab and thin strip caster, the productivity. Hot charging, probably we should do more of that and understand that better. Steckel mill is very cool. We had one in Conshohocken as part of Bethlehem Steel. Came to IPSCO. There were Steckel mills. It's so flexible. You can make coil, you can make plate. You can roll very light gauge. We're rolling at Montpelier down to 3.2 millimeter. Thermomechanical control processing, all the metallurgy, the deep metallurgy that we've learned about control rolling, accelerated cooling, how you can save alloys and improve productivity. The computer models, getting better and better every day for improving process consistency and quality. When I started, we used to write reports by hand. There was no word processing. The fact that we have word processing, PowerPoint presentations, Excel spreadsheet. We used to get big graphs, paper, and taking down data by hand is so much faster now. You got digitized micrographs, macrographs, electron micrographs. All those things are just so much faster. The engineers are so much more efficient.
Throughout your career, what are some technical challenges that you experienced towards the beginning, but now seem rather trivial?
Well, hydrogen flaking, although we still have hydrogen flaking from time to time, that was a major problem. And largely, although in the Bethlehem plant we had a vacuum degasser, there still was a problem with ESR, moisture pickup in the lime, the slags that we use in the ESR. It's much, much better now. Low sulfur steels, we're making 2 ppm sulfur levels these days. It's just incredible. The levels were 2 orders of magnitude higher than when I started. Calcium treatment, the Sunday Abraham and I wrote a very good paper because people don't understand calcium treatment, including most physical metallurgists, and I think that's made a big contribution. But to get 100% calcium treated, where you modify all the sulfides, to become spherical and they don't become elongated during rolling, and control the oxides, to liquefy some of the oxides in the liquid steel making. Making low nitrogen steels, I still hear this, that, it's electric furnace, the nitrogen levels are too high. We're making 35 ppm nitrogen electric furnace with vacuum degassing today. And then copper, and I heard this a lot, the mini mills will never make it. The copper level's too high, they're going to have hot shortness. We're making high copper steels routinely, 35 copper in a steel without issue.
Where do you see the steel industry 20 years from now?
This is a hard one. It's hard to look to the future, and maybe this is more near future than 20 years, but you're going to have fewer people, I think. You're going to have more automation. You're going to have more reliable sensors in the mill. You're going to collect big data. You're going to have these huge models. You're going to have more computer programs, more computer models. You're going to be able to simulate things. This is going to make the process more consistent. And of course, SSAB and others also working on hydrogen in their iron making, and to make sponge iron and fossil-free steel with hydrogen, I think is exciting. But that's near future. I can't really project out 20 years because things have changed so much during my career.
Are there any misconceptions that you repeatedly see about the industry that you wish you could change?
You still hear from people, steel industry is a dinosaur. It's a dirty, rusty business. And you walk in today's mills, you got modern computers, modern pulpits, modern equipment. It's not like that at all, but that's still a misconception. And then I've heard this from academia, particularly those that are not involved with the consortia, steel consortia that are out there that, what more do we need to know about steel? We know just about everything. There's very little research that needs to be done. There's very little work that needs to be done. Totally a misnomer. That kind of bothers me, that you have the professors that are teaching students, and I would assume that they're teaching that, steel is uninteresting. It's all, we know everything about steel. We don't.
How would you rate your work-life balance during your career?
Terrible. I'm a workaholic. I've been a workaholic. But the interesting thing is, work-life balance, that wasn't even a thing when I was a young engineer. I mean, I was taught by my parents, essentially, good things happen to people that work hard. You're supposed to work hard. And that's what I did. I brought the briefcase home every night. Didn't always open, and for 13 of the years, I coached, and so I left work early. I left work at 4 o'clock. We had practice, we had games, whether it be Little League baseball or a soccer game or basketball or girls softball or whatever. I was there for my kids, but then I'd come home. They would go to bed 9 o'clock. The briefcase would open. I might do work, even on vacation. I love what I do. It was really not a problem for me.
How did you develop such a passion and drive for working in the steel industry?
The bottom line, you get steel in the blood. And I've said that for a long time, but I've heard a lot of other people say that, including some of the other captures. So, I don't know. Every day, I seem to be a little bit different. I learned something every day. It was exciting. There were always exciting problems to work on. And I think, as you go on in your career, the more you know about steel, the more you realize how little you know about steel. So, there's so much more to learn. And the other cool thing is, nobody knows everything about steel. So you can find your niche or area where you're the expert, like ultrasonic testing. You're the expert. And so, I think that's kind of neat that, there can be a whole lot of metallurgists in a room, but you may be the expert on ultrasonic testing. I may know something about accelerated cooling, and the next guy knows something about steel making. But nobody knows it all, and we all need to work together, and it's kind of neat. When I worked in the Bethlehem plant and Homer Labs, I used to drive past the steel mill every day, and it's just driving past the steel mill is just so cool. Once you know what's going on inside, you used to get excited.
What attributes do you have that have contributed to your success in the industry?
I'm not the smartest guy in the world, but I'm a hard worker. I'm going to put the time in. I'm going to read everything I possibly can read on a subject. I'm going to become the world expert on a subject. I think through athletics, I'm competitive. So, for most of my career, I'm the guy with the master's degree. There's a lot of guys that work for me, colleagues of mine with PhDs. I'm like the underdog, so I got to be at least as good or better. So I think that's driven me to some degree, helped me be an overachiever. I'm a good planner. I now write well. When I first started, I wasn't very good. I write well. I communicate well. I read everything. I mean, almost to a fault that some of the stuff, now, why are you reading this? I mean, but I know I got to read everything. I always surrounded myself with good people. So I had people tell me, like the Bruce Bramfords, or Steve Hansen, or Sunday Abraham, or Keith Taylor, or whoever, that's not a great idea. That's not one of your best ideas or whatever. I think it's important to have somewhat of a safety net, and then have people that, when you do have a good idea, really champion and get behind you. And so that's been good. I have a practical approach to problem solving. I feel that sense of urgency. I'm not a scientist. I am an engineer, and I'm willing to take risks. And a lot of times we don't have all the information. We have to make a decision. And I'm not afraid to do that. I'm very loyal. I'm honest. I'm trustworthy, I think.
Do you think that luck played a role in your successful career?
Yeah, this is an interesting question, and I do. I mean, why did I pick Muhlenberg College? I got accepted to these other 5 engineering schools. It was just kind of gut feeling. I mean, the sun came out, just felt comfortable on campus. I liked people were friendly, could meet to make this sports team, and then I met my wife. Finding ferrous metallurgy, we talked about when I was at Penn, it was the halcyon for ferrous metallurgy. There's no ferrous metallurgy being done there now, but I was at the right time in the right place. I mean, I met all these people and working on cool stuff. Starting in the Bethlehem plant, that was not my first choice, and that's where I ended up, and it turned out to be a great place to learn because they had all this equipment, all these things that I learned. Working for EPRI, I mean, I worked on 2 EPRI projects, actually more than that. There were subsequent projects when I was at Homer Labs that we did with EPRI. Who knew? It turned out to be a great thing. And then moving to IPSCO. So I'm moving from integrated steel mill to IPSCO, a mini mill. How's that going to work out? How am I going to like that? Turned out to be a great place to work, particularly timing. Just starting up new building and starting up new heat treat facilities, so exciting time. And then, having the job of a lifetime that, hey, SSAB management saying, we need to build a research center. And I want that job. I want that job. And I think I was a perfect candidate for it. And it was, to do all the things that we did and to see where the center is doing great and thriving and doing good work. Very proud of that.
Is there anything that you would have done differently? And how would it have changed where you are and what you have done?
I often thought about a PhD. And so why did I leave Penn? I think I was tired of going to school. I had cockroaches in my apartment. So we'd bring an exterminator in, and they moved to the next apartment. And the next apartment would bring an exterminator, and they moved back. I wanted to get married. I wanted to start married. I didn't have any money. I wanted to make money. And it would have been nice to get that PhD. And actually, Bruce Branford, when I was working at Homer Labs, he said, you should go back and get your PhD. And Steve Hansen told me, he said, you're doing a great job. You're not going to make any more money with a PhD, So once you start working, it's just based on your contributions. You get paid. So I was making a nice contribution, and they were taking care of me financially. But it's embarrassing. I go to conferences, and here's Dr. Abraham, here's Dr. Taylor, here's Dr. Denji Bai, and here's Mr. Bodnar. And it's a little bit embarrassing, but I'm happy to be associated with them. So maybe I have a PhD by association, maybe.
Finally, what career accomplishment are you most proud of?
The Research Center. I'm really proud of that. All the things that I've done, it's just kind of culmination of my whole career to build and construct and, hire the people, hire the equipment. And, compared to other labs, we use like 95% of the equipment we bought. Yeah, I made some mistakes in what we bought, but we're using all that equipment. Some other labs that maybe use 50% of the equipment, yeah, they got a lot of equipment. They don't use it. It's old or whatever. Hired good people, doing good work. Really, really happy.
Is there anything else you would like to say?
Well, I want to thank you, Andrew, for conducting this interview. You've done a great job, and I think it's important to have a young guy like yourself do the interview. I really appreciate the opportunity from AIME to reflect on my career, and I've had a great career. It's been nice. Thank you.
And thank you, Rick, for sharing your story with AIME and AIST.
Thank you.